All right, so refer to the first video in this ALEKS topic for the background conceptual information on how we approach these problems. I'm just going to go ahead and jump straight into the work for this second example. So we have an aqueous solution at 25 degrees Celsius that has a hydroxide concentration of 3 times 10 to the minus 9 moles per liter, or molarity. Those are units of molarity. Calculate the hydronium ion concentration and be sure that your answer has one significant digit. So let's write our knowns here. Our hydroxide ion concentration is 3 times 10 to the minus 9 molar. And they want us to find the hydronium ion concentration. What is that? What is that concentration? Well, we can find this by using the ion product constant for the ionization of water, and that is 1.0 times 10 to the minus 14. And so when I write the equilibrium expression for the auto ionization of water, it's Kw is equal to the concentration of hydronium times the concentration of hydroxide ions. And so what we're going to do is we're going to plug in this, which is given. We're going to plug this in, which is a constant, and we're going to be able to solve for this. Okay? So let's plug in our givens, our given, which is the hydroxide ion concentration, and let's plug in our constant here and solve for the concentration of hydronium ions. So this now becomes 1.0 times 10 to the negative 14, and K has no units. Kw has no units, just like Kc. It's going to be equal to this, which we do not have, times this. Okay? And so hydronium ion concentration is going to be equal to Kw divided by the hydroxide ion concentration. I'm going to omit the units again because K, the ion product constant, has no units. Okay? Now remember, when you put this into your calculator to solve for hydronium ion concentration, I use this button on my calculator to eliminate the likelihood that I make a mistake with order of operations by adding carets and times 10. I use that. So if you find that capital E, not the lowercase e, but if you find the capital E button on your calculator, and if you just put in the power here, which is negative 14, remember E substitutes the times 10 function. Okay? Here's 3, and it'd be E, and this is negative 9 to the minus 9. So what we get in our calculator is we get a really, really small value again. And this is a concentration, so it'll be molar. So let's place this into scientific notation and round it to one significant digit. So it'd simply be 3 times 10 to the minus 6 molar. So once again, we know that for pure water at 25 degrees Celsius, this is 1 times 10 to the minus 7, and this is 1 times 10 to the minus 7, and this is 1 times 10 to the minus 14, right? Well, in this solution, the hydroxide ion concentration is not 1 times 10 to the minus 7 molar. It's different. It's this. And because this is in equilibrium, this auto-ionization of water is in equilibrium, well, this also cannot be 1 times 10 to the minus 7, but needs to be something different, and it needs to be a value so that when I multiply this concentration by this concentration, I get 1 times 10 to the minus 14, which is the ion product constant. So all that is to say that we can actually check our answer to make sure that it is correct. How can we do that? I can take this concentration, 3 times 10 to the minus 6, which is the concentration that we have found for hydronium, and I can multiply it by the given concentration of hydroxide. So this is the hydronium ion, and if this is going to be hydroxide, what was it? It was 3 times 10 to the minus 9. What do I get when I multiply those two concentrations together, or what is the product of the concentration of those two ions? Well, it is very close to the value of the ion product constant. It is 9.9 times 10 to the negative 15. And the only reason it is not 1 times 10 to the negative 14 is because of this value. Remember, we rounded it to one significant digit. If you actually put it into your calculator as what it was, which was the repeating 3 of, then it'll come out into your calculator not as that, but as 1 times 10 to the minus 14. If we go back up here to the top, that is what the product of the concentrations of hydronium and hydroxide should be for water at 25 degrees Celsius. It should be equal to that constant.